Okay, so I is the square root of negative 1, right? So then by definition, I squared would be equal to negative 1. So then what is I to the third?
Just kidding.
Negative 1i.
Negative, yeah, negative I. Because you're taking this negative 1 and multiplying it by I, right? So it's negative I. Then think about this. What is I to the fourth? Here's how I think about it. It's I squared times I squared. What's I squared? It's negative 1, right? Times negative 1 gives me positive 1. All right? So let's see what happens when we keep going. Okay, what about I to the fifth? It's not negative 1. Negative I. Yeah. Because now we're taking this one, or it's not negative I, it's just I, isn't it? It's this one times this. I to the fourth, because you can break it down like this. You can say it's I to the fourth times an I, right? And what do we say I to the fourth is?
1.
It's just 1. So it's 1 times I just gives me I. All right. I to the sixth. Well, you can break it down into I squared times I squared times I squared. So it's negative 1 times negative 1 times negative 1 gives me negative 1. So I to the seventh. Okay, it's I squared times I squared times I squared times I.
1. No.
What did we say I to the sixth was? Negative 1 times I. So it just translates to negative I. And then lastly, I to the eighth. Okay. Yeah, it's just 1. A lot of ways you can break that down.
I did the 4th.
You did 4 and 4? Okay. I to the fourth times I to the fourth, which we said I to the fourth is just a 1 times 1. So I to the eighth is just a 1. A lot of ways you can break it down. But what I wanted you to see is it becomes a cycle. They all just start repeating, right? Every 4, it comes back to I, negative 1, negative I, positive 1. I, negative 1. Huh? So it repeats itself. So that is the cycle of I. Now, first, you got a lot of little operations to remember how to do. I'm hoping you recall them. So the first one is dealing with complex numbers. A complex number is just a number that has a real component and an imaginary component, meaning like here, this has a 4, which is real, and the 3i is the imaginary. But together, this makes a complex number. We always write it like this with the imaginary stuff in the back. All right? So when you want to algebraically work these or simplify these, you're just going to follow PEMDAS and then combine like terms. So if I follow PEMDAS and deal with my parentheses, that means I have to distribute a negative here. So minus 2 minus I plus 10 minus 5i. Okay, now I want to collect like terms, so I'm going to take my real numbers, 4, negative 2, and 10. What do you get when you add all those?
12.
Yep, you just get 12. Oops, I want my highlighter. 12. And then we're going to combine the imaginaries. 3i minus 5i.
Negative 3i.
Negative 3i. Does that make sense? So you're just combining like terms, and this is where you leave it. You can't do anything else with it. Now, number 2. At first glance, you're like, there's no i's in this. This is not complex numbers, but it is because you have square roots under the radicals. Alrighty? So what you're going to need to do is simplify those radicals. Alright, so let's look at this. Square root of negative 12. You're going to factor everything down and see how we can simplify it. So negative 12 is negative 1 times 4 times 3. And can we keep factoring anything? We can take the 2's out, right? So we can take numbers out in pairs. And I, we know the square root of I. We know the square root of negative 1 is I. So that comes out as I. That leaves the square root of 3 in there. Because it doesn't have a partner to come out. Now, let's do the same thing with the other radical in the question. Negative square root of 75. Negative 1 times 3 times 25. Well, 25 factors down to 5 and 5. So I can take a 5 out, and then I can take I out because of the negative 1, and that leaves the square root of 3. Do you remember this stuff?
Yeah, we did.
You should have, but that doesn't mean you remember it always, so good. Well, you're just a special one, Nixon. Good job. All right. Now I'm going to rewrite my question with these in place of those radicals, those original radicals, okay? So negative 3 plus 2i square roots of 3 plus 5 plus 5i square roots of 3. And now we're back to the same game we did before. We're going to take the real parts and combine those, and the imaginary parts and combine those. So negative 3 plus 5 is 2. 2i square roots of 3 and 5i square roots of 3. I can combine them because they both have just square root of 3 and an I. 7i square roots of 3. And that's it. Nixon. All right. Moving on. Let's talk about number 3. To simplify this, what would my first step be here? Good. You're going to have to FOIL this guy. It's being squared, isn't it? So 3 minus 2i times 3 minus 2i. Let's FOIL this. I'm just copying that part down. Let's FOIL this out. So I have 9 minus 6i plus 4i squared. So this would be 9 minus 12i. 4i squared becomes minus 4, right? What'd you say?
5 minus 12i.
Yeah. So 5 minus 12i, right? Now I'm going to bring all this stuff down. Minus, now this negative gets distributed, minus 1 plus 8i. Distribute that negative. Did I lose anybody? Now I combine like terms, like we did. 5 minus 1 is 4. Negative 12 plus 8 is minus 4i, and I'm done. Are we good? Yeah. Okay, last thing. We've done adding, we've done subtracting, we've multiplied. Now we divide complex numbers. So remember I always said we can't divide by 0 before. You can't divide by an imaginary number either. All right, so we have to get rid of any situation like this where an I is in the denominator. If it's in the numerator, we don't care. If it's in the denominator, it's problematic. So the way we get rid of it is multiplying by its conjugate, which looks like this. 3 and the 2i don't change. But what does change is the sign in the middle. So it was a plus, so now it's a minus. And what you do to the bottom, you have to do to the top, so that what we're adding to the equation is equivalent to 1. All right? You know 3 over 3 is equal to 1. That's not going to change the value. So this is what we're doing. All right, now you just do multiplication. On the top, all I need to do is distribute the 6. All right? So I have 18 minus 12i. Everybody good with that? The bottom, I'm going to FOIL it. So 9 minus 6i plus 6i minus 4i squared. Now I got some cleanup to do here. If you did it right, your conjugate's right, the middle terms should cancel one another out. Those go away. And now I have 9 minus 4i squared is really a positive 4, isn't it? So it's going to simplify quite nicely, and it will end up being 18 minus 12i over 13. Yeah. Oh, 13. Ring a bell? We good? Okay. Write in standard form. Okay. Basically, we're just simplifying this guy. All right? So let's simplify first the 4i to the 5th. Okay, so there's 4. I to the 5th could be rewritten as I squared times I squared times I. Well, I squared is negative 1, isn't it? Okay, so what's a negative times a negative? Positive. So this term right here simplifies to just 4i. I to the 3rd, we can rewrite that as I squared times I. I squared is negative 1i, so it's minus negative I. So this is going to be minus I. And then I just subtract, so it's 3i. It's simplified to 3i. Okie dokie. Now, before I turn you loose, there is one question on your quiz tomorrow that historically students miss. I'm trying to give you like a little hint on this, a heads up on it. Let's see if you can figure it out. If not, I can help you. So what if I gave you something like this? What does that mean? So the first thing I would do is realize this cubing thing is going to happen to both parts, the top and the bottom. So let's stop and think. What is 3 times 3 times 3?
27.
Yeah. So it's 27 on the top. What's 2 times 2 times 2?
8.
Good. 8, and then it'll be I to the 3rd. All right. We're not done, though. Remember, you can't leave an I in the denominator. We can't leave I in the denominator. So how can we get rid of I? Any ideas? So here's what I would think. Here's my logic, okay? Leaving 27 alone, 8 alone. I am going to rewrite it as I squared times I. Because what's I squared? Negative 1. So now I can write it as 27 over negative 8i. Still have an I though, don't I? But if I can get that to I squared, it would become a real number, wouldn't it? So all I have to do is multiply by I over I. Because this whole thing is equivalent to 1. So it's going to be 27i. And then what's going to happen to the bottom here? It's going to be negative 8 times a negative 1, which makes it positive 8, right? A lot of little steps on that. Did you get them all? Yay, nay, maybe, sort of. Got it? Need another example like that? Nope. All right, cool, Leo, then. All right, so the rest of the period is your work time on 2.1. If you've not already checked it off with me,